Hello everyone. Okay, so in this video we are looking at complex division and the conjugate of a complex number. So what's the conjugate of a complex number? Well, first of all, if we're asked to find the conjugate of a complex number, so look at this here. So it's just a z with a line on top, and that just means we change the sign of the imaginary part. So if I have z is equal to 3 minus I, the conjugate will be 3 plus I. If I have z is equal to 4 plus 6I, I'm going to have z is equal to, the complex conjugate is 4 minus 6I. So that's all we need to know about the conjugate. And then finally, if I multiply a complex number by its conjugate, I will always get a real number, right? If I multiply a complex number by its conjugate, you will always get its real number. And you're probably asking, what does this have to do with anything? Well, it's going to lead us right into complex division. So, complex division, what's that mean? So I have the sum here, 2 plus 3i all over 1 minus 2i. And as we're aware, fractions mean division. So, I don't like this. Don't like this. I don't like having a complex number in my denominator. So, if only there was a way I could get rid of the complex number on the bottom. Well, I can. You multiply, this goes for any complex division like this, you multiply the top and bottom by the conjugate of your denominator. So I'm going to multiply the top of my fraction by 1 plus 2i, and then I'm going to multiply the bottom of my fraction by 1 plus 2i. So top by top, bottom by bottom, 2 plus 3i times 1 plus 2i all over 1 minus 2i, 1 plus 2i. So taking parts, multiply the top. So I'm going to have 2 times 1 is 2. 2 times 2i is 4i. 3i times I. So 3i times 1 is 3i. And then 3i times 2i is going to be 3 times 2 is 6. And then I times I is I squared. Then my numerator, 1 times 1 is 1. 1 times 2i is 2i. Minus 2 times I is minus... So minus 2 times 1 is minus 2i. Minus 2i times 4i is going to be minus 2 times 2 is minus 4. I times I is I squared. So I have here 2 plus 7i plus 6 times minus 1 all over 1 minus 4 times minus 1. So my top one is going to be now, so 2 minus 6 is going to be minus 4 plus 7i all over 1 minus negative 1. So it's going to be 1 plus 4. So my answer here is going to be minus 4 plus 7i all over 5. Now, when we want to finish it off, I want to leave it in the form a plus bi. Okay, I want to leave it in this form always. So I don't really like this. So what we're just going to do is we're just going to divide each term by 5. So my final answer is going to be minus 4 over 5 plus 7 over 5i. And that is how we perform complex division. So let's look at some more examples here. So let z1 equal minus 3 plus 4i and z2 equal 4 plus 3i, where I squared is equal to minus 1. Find z3, which is z1 divided by z2. So minus 3 plus 4i all over 4 plus 3i. So I have a complex fraction. I multiply the top by the conjugate of the denominator. So 4 minus 3i all over, multiplied by 4 all over, sorry, 4 minus 3i, and then multiply the bottom by 4 minus 3i. So that's going to be minus 3 plus 4i times 4 minus 3i all over 4 plus 3i times 4 minus 3i. Multiply the top brackets. I'm going to have here minus 3 times 4 is minus 12. Minus 3 times minus 3i is plus 9i. 4i times 4 is 16i. And then 4i times minus 3i is minus 12i squared. All over. 4 times 4 is 16. 4 times minus 3 is minus 12i. 3i times 4 is plus 12i. Minus 3i times minus, 3i times minus 3i. 3 times minus 3 is minus 9. I times I is I squared. Excuse me. So let's simplify the top. So I'm going to have here minus 12 plus 25i minus 12 times minus 1 all over my bottom here. See how the i's are going to cancel? I'm going to have 16 minus 9 times minus 1. Because remember, I squared is minus 1. So at the top, I'm going to have minus 12 plus 25i. Minus 12 times minus 1 is plus 12. All over 16 plus 9, which is 25. Finally, my numerator, simplify it. Minus 12 plus 12 is 0. So I'm going to have 25i all over 25, which is just going to be equal to I. It says leave in the form a plus 0i, so my answer is 0 plus I. That's my final answer there, 0 plus I. So that was 2021. 2022, Z1 is equal to 3 minus 4i. Given that Z1 times Z4 is equal to 29 plus 3i, determine Z4. Well, I have this, Z1 times Z4 is equal to 29 plus 3i. Therefore, Z4 is going to be equal to 29 plus 3i divided by 3 minus 4i. Oh, sorry, should we simplify that before? 3i divided by Z1. So divided both sides by Z1. And that's going to be 29 plus 3i divided by 3 minus 4i. Because 3 minus 4i is what Z1 is equal to. So multiply top by 3 plus 4i. Multiply the bottom by 3 plus 4i. So 29 plus 3i times 3 plus 4i is equal to 3 minus 4i times 3 plus 4i. So 29 times 3 is equal to 57. 29 times 4i is equal to, take out my handy dandy calculator. So 29 times 4 is going to give me 116. 116i. 3i times I is 9i. The 3i times 4i is 12i squared. All over 3 times 3 is 9. 3 times 4i is plus 12i. Minus 4i times 3 is minus 12i. Minus 4i times 4i is going to be 4 times minus 4 is minus 16. I times I is I squared. So I have here 57 plus 9, 9i plus 116i is plus 125i minus 12, because 12i squared is minus 12, all over. These are going to cancel out here, and I'm left with 9 plus 16, which is 25. So 57 minus 12 is equal to 45 plus 125i all over 25. So Z4 is going to be equal to 45 divided by 25 plus 125 divided by 25i. And this is going to be 5. So 9 over 5 plus 5i is equal to Z4. Right. We have one more question left. Again, this is very similar to the last one for the first question we did. So Z1 is equal to minus 2 plus 3i. Z2 is equal to minus 3 minus 2i. Find Z3, which is equal to Z1 over Z2. Express Z3 in the form x plus yi. The thing is literally a carbon copy. I'm pretty sure. Yeah, the 2021 question, literally a carbon copy. Same thing, different shape, right? So let's do it here. So Z3 is equal to Z1. Z1, which is minus 2 plus 3i, divided by minus 3 minus 2i. So I'm going to multiply the top by the conjugate denominators. It's minus 3 plus 2i over minus 3 plus 2i. So minus 2 plus 3i times minus 3 plus 2i minus 3 minus 2i times minus 3 plus 2i. So multiply out the top. Minus 2 times minus 3 is plus 6. Minus 2 times 2i is minus 4i. 3i times minus 3 is minus 9i. 3i times 2i is going to be 2 times 3, which is 6. I times I is I squared. All over minus 3 times minus 3, which is 9. Minus 3 times 2i, which is minus 6i. Minus 2i times minus 3i, which is 6i. Then minus 2i times 2i, minus 2 times 2 is minus 4. I times I is I squared. So my top here is going to be equal to 6 minus 13i minus 6 all over. These are going to cancel. 9 plus 4, which is 13. Sorry. 9 plus 4, which is 13. Top here, they're going to cancel. 6 minus 6. So I'm left with minus 13i all over 13, which is just going to give me minus I. But you want it in the form a x plus yi. So my answer is going to be 0 plus, or let's say 0 minus I is equal to Z3. That's my final answer there. Right, I think that was literally a carbon copy of the first question. Right, hope this video was some help, and I'll catch you guys later. Bye.